Good morning. I think many of you have been doing well. Of course, I know that some students were not satisfied, but majority of you have been doing well. So we have one more midterm exam and then final. If you do well in exam 3, then your final exam score will be good because you did first and second exam well and third exam well, and then just you will be fine in the final exam. Do you have any question? Let's start at 7.4. 7.4 is about trigonometric equations. Find all solutions of the given equation. If you cannot find the exact answer, then round to 2 decimal places. The first question is cosine of theta plus 1 equals 0. If you look at the equation, then you notice that this is a linear equation for cosine. When we had a linear equation with a polynomial equation, then when that is degree 1, we had only one solution. But this is about trigonometric equations. So even if the equation itself is degree 1, there are infinitely many angles which satisfy the given equation. Of course, when you think about just the cosine part, that will have only one solution because you can solve for cosine, then cosine theta must be -1. So cosine can be uniquely solved, but the trigonometric equations problem is about finding the angle which satisfies this equation. The trigonometric functions are periodic function, so same pattern happens all the time, just infinitely many times. So whenever we think about the trigonometric equations, it tends to have infinitely many solutions. When we solve for cosine, cosine value became -1. So this is a minimum value, right? When we have minimum, maximum, or 0, we tended to use the graph of the function. This is one cycle of the cosine, and it is enough to think within a cycle. So cosine value must be -1. That happens when theta is pi, right? So when we think about the solution within one period, 0 to 2 pi, then we have only one solution, pi, but cosine function is 1 to 1. So we have to think about coterminal angles. Coterminal angles are related by 2 pi k. So whenever we add 2 pi times whatever the integer is, when we add that, we will get the same value, right? So there are infinitely many answers that can be expressed in this way. Any question? Yeah. Less part. This one is k, and k may be integer, so it's -1, 0, 1, and so on, right? And so this expression covers pi, 3 pi, 5 pi, and so on, because we are adding 2 pi, right? This one, 2 pi. From here to here, we have 2 times 2 pi, right? And we can do the other way. Then negative pi, -3 pi, and we can achieve it by subtracting, right? Yeah. No, because integer means -1, -2, and all the positive numbers. So if I write something like a natural number, then I have to do plus or minus, right? But in this case, I said integer. Any other question? Second problem is square root of 2 sine of theta plus 1 equals 0. So the first step is solve for the trigonometric function. So we will get sine of theta by itself on the left side. The first step is we will subtract 1 on both sides. The square root of 2 times sine of theta equals -1. And we divide by square root of 2 on both sides. Then we have sine of theta equals -1 over square root of 2. So by looking at the solution for sine of theta, what we notice first is a negative 1 over square root of 2 is not 0, maximum or minimum. In that case, we have to use the reference triangle. 1 and square root of 2 is involved, so 45, 45, 90-degree triangle is involved. So this angle is pi over 4. The sine value is square root of 1 over square root of 2. So this part will give us the information about the reference angle by relating it to the typical reference triangle. So reference angle is pi over 4. And then we notice that there is minus, this one is negative. So this time, instead of using the graph, I will draw the angle in the quadrant. Sine is positive in the first and second quadrant where y values are positive, but that is negative in the third and fourth quadrant. So I would draw the angle in the third and fourth quadrant with the reference angle pi over 4. So the first thing we have to think about is the solutions within the first period. We found 2 angles. So let's do it. This angle is obtained by adding this amount, which is pi, and this amount, which is pi over 4. So that becomes 4 pi over 4 plus pi over 4, which is 5 pi over 4. So this is one angle. And we want to think about this angle this time. So there was a question, so I think it is better to go through the equation. So when we think about theta plus pi over 4, when we add those 2 angles, it would be 2 pi, right? So we subtract pi over 4 on both sides, then we get theta equals 2 pi minus pi over 4, right? So that is 8 pi over 4 minus pi over 4, which is 7 pi over 4. So there are 2 angles. And then we have to generalize it because the question asks you to figure out all the angles which satisfies the equation. So we use the period, so 2 pi times k, and 7 pi over 4 plus 2 pi times k. Of course, both k's are integers. So we have 2 solutions for this question. What's important to hear is what's in front of k is this one is period. The reason I'm telling you this is we are working on sine. Therefore, we thought about the solution between 0 and 2 pi within the first cycle. And then we generalize it. But when we think about tangent and cotangent, we have to set a little bit different strategy because period is pi. So instead of adding 2 pi, we will add pi k. Yeah. Seven pi. Yeah. 8 pi minus pi, 7 pi. Any other question? Let's do number 3. Number 3 is square root of 3 times cotangent of theta plus 1 equals. This time the function's period is pi. So when we finalize the answer, the pattern will be a little bit different. But the first step is isolate cotangent. So we have square root of 3 cotangent of theta equals minus 1, and we divide by square root of 3 on both sides. So we have cotangent of theta equals minus 1 over square root of 3. So 1 and square root of 3 are involved, and so that's related to 30, 60, 90-degree triangle. This is about cotangent. So we can rewrite that as negative adjacent over opposite. So adjacent is 1. This is adjacent, and this is opposite to the angle pi over 3. That's what we know. So pi over 3 is a reference angle. Right? And then keep in mind that cotangent's period is pi. So all we have to figure out is the solution between 0 and pi, and then we will generalize. Cotangent is positive in the first quadrant. In the second quadrant, x and y have different sign, so that is negative. And we already know the reference angle is pi over 3. So this angle is the unique solution between 0 and pi for this equation. And obviously, the angle value is pi minus pi over 3, which is 2 pi over 3, right? So we have 2 pi over 3 within a period. So we want to generalize it so that we can represent all the solutions. This time I would add pi times k. Pi is a period. So I don't use 2 pi, I would use pi. When we look at the quadrant and we want, if we just add the angle, which satisfies the equation, then obviously cotangent is negative in the fourth quadrant. And because of the same reasoning, pi over 3 is the reference angle, right? And when we compare this angle and this angle, the difference is pi amount. That's because cotangent is periodic function. So we realize that this equation covers all the solution. Any question? No question? Now we want to use factoring to solve the problem. The next problem is tangent of theta times sine of theta plus sine of theta equals 0. I think everybody noticed that sine is included in both terms. So sine should be taken out, but there were some students who couldn't understand the factoring process. So let me elaborate a little bit to make things a little bit easier. This is sine of theta, but we can understand that as 1 times sine of theta equals 0. And then sine of theta is obviously the common factor, which we can take out. So sine of theta times open parenthesis, tangent of theta plus 1 equals 0. From here, we have 2 cases because 2 things are multiplied and become 0. So we can say that sine of theta equals 0, or tangent of theta plus 1 equals 0, right? So one equation will be split into 2 linear equations. This one is 0, so I would use the graph of sine here. So this is the graph of sine. And then I realized that the solution occurs every pi in this case, because 0 pi, 2 pi, 3 pi, and so on. So what can I do? In this case, I would write k times pi. K is an integer. And so this is one part of the solution. So tangent of theta plus 1 equals 0. For this case, when we get tangent by itself on the left side, it becomes -1, right? And then we realize that tangent doesn't have any bound. Therefore, -1 is not minimum or maximum. So maybe we can relate that with 45, 45, 90-degree triangle, because this can be rewritten as -1/1, right? And so pi over 4 is a reference angle. So far we worked on this part, and the next part we have to notice is tangent is negative, and we know that the period of tangent is pi, right? So I would draw the angle in the quadrant between 0 and pi because of the period condition. And tangent is positive in the first quadrant and negative in the second quadrant because x and y have different sign. And we know that the reference angle is pi over 4. Obviously, this angle is pi minus pi over 4. That is 4 pi over 4 minus pi over 4. So that is 3 pi over 4. So what can we say about this? 3 pi over 4 plus pi times k, right? Because period is pi. So again, tangent is negative in the fourth quadrant when we look at the entire quadrant. And we know that this is pi over 4. The reference angle is pi over 4. But when we think about this angle will be obtained by adding pi. So that is included here. Any question? The next one is about 4 times cosine squared of theta minus 1 equals 0. We want to solve for cosine. So we solve for cosine squared first, then we have 4 times cosine squared of theta equals 1. And then I will divide by 4 on both sides. Then cosine squared of theta equals 1 over 4. Therefore, when we square root on both sides, I would get cosine of theta equals positive square root of 1 over 4 or negative square root of 1 over 4. 1 over 4 is 1 over 2 squared, right? And therefore, cosine of theta equals 1 over 2 or negative 1 over 2. Let's work on cosine of theta equals 1 over 2, and the other one is cosine of theta equals negative 1 over 2. Again, this is not maximum, minimum, or 0, so we will relate that with the reference triangle. So 1 is adjacent to pi over 3. So pi over 3 is the reference angle. Right. And then what I said was you have to look at the number. Is that positive or negative? That is positive. And what is the period of cosine? That is 2 pi. That is period. So we will think about the entire quadrant, and we will locate the angle where the cosine values are positive. Cosine values are positive when x values are positive, so angles will be located either in the first or fourth quadrant with the reference angle pi over 3. So the first solution is pi over 3, and what is this angle? This angle is 2 pi minus pi over 3, right? So that is 5 pi over 3. So we have two solutions here. And then the period is 2 pi, so 2 pi times k, right? We have to add those. And then for the right side, so we have two solutions here. And on the right side, cosine of theta equals -1/2. So the same thing, we will use the same reference triangle. So reference angles will be the same, but the value must be negative. Of course, cosine has period 2 pi. So the only change will be locating the angle either in the third or fourth quadrant with the same reference angle. This is pi over 3, pi over 3. So for this part, that is pi minus pi over 3. So that is 3 pi over 3 minus pi over 3, which is 2 pi over 3, right? And then we want to think about this one. So from here, that would be pi plus pi over 3. So that is 4 pi over 3. We have two solutions like this. Any questions so far? So we generalize it to figure out all the solutions. So we have 4 pi over 3 plus 2 pi k and 2 pi over 3 plus 2 pi k. So we have 4 solutions here, but what you can see is this and this are related to pi. If you add pi, then you will make this. If you add pi to 2 pi over 3, then you will get 5 pi over 3, because we are thinking about plus or minus. So I think you can write pi over 3 plus pi k, or and 2 pi over 3 plus pi k. I don't recall how the pattern of the question is given. So in this case, if there is no instruction, then 4 answer version and 2 answer version must be accepted. But there is a possibility that they just put plus 2 pi k, and you have to fill the blank with 4 numbers, but I cannot remember how the question is asked, so you have to be careful. Any question? The next question is about the quadratic equation. So we will go back to the intermediate algebra class first to factor it, and then we will discuss trigonometry. If you look at the pattern, then that is 2 times cosine squared minus cosine of theta minus 1. So obviously that is associated with quadratic equation. To relate this trigonometric function, a trigonometric equation, with what we learned in intermediate algebra, I would put x equals cosine of theta. Then x squared equals cosine squared of theta. So we can rewrite that as 2 times x squared minus x minus 1 equals 0. And then it is intermediate algebra factoring problem. You can use any method to solve this equation, factor this out. But my favorite method is listing 2 numbers whose multiplication becomes 2. In this case, this is a prime number, is this 2 times 1 or 1 times 2. And again, this one is the simplest number, so 1 times 1 will make 1. And then I would cross multiply. I'm doing FOIL in this with this method. Just so 2 times 1 will make 2. 1 times 1 will make 1. And our rule is when we add the 2, we have to get the number in front of x negative 1. So that can be achieved only if we put negative sign in front of 2. And then I would transfer that negative sign here. And then I will make 2 boxes like this and connect like this. And then the factoring is finalized. So 2x plus 1 times x minus 1 equals 0. So that means we have 2 equations, 2x plus 1 equals 0, or x minus 1 equals 0. So we subtract 1 on both sides, then we have 2x equals minus 1. And we add 1 on both sides, then we have x equals 1. This is about just a common factoring in the intermediate algebra, but we are doing this for solving the trigonometric equation. X was indeed cosine, so we put that back here. Then we have 2 times cosine of theta equals minus 1. In this case, we have cosine of theta equals 1. So when we solve for cosine, we have cosine of theta equals -1/2, which is negative. So we locate the angle in third and fourth quadrant because cosine values are negative in third and fourth quadrant. We already know that 1/2 has reference angle pi/3. So the same reference angle pi/3. For this angle, that can be obtained by pi minus pi/3, which is 2pi/3. And for this angle, we have pi plus pi/3, which is 4pi/3. So we have two sets of the solution from this equation. Those will be 2pi/3 plus period of cosine, which is 2pi times k integer. And the other solution is 4pi/3 plus 2pi times k. So these two solutions are here. And then for this one, we noticed that 1 is the maximum, so maybe we had to use the graph of cosine. So this is 2pi, and this is 0. And we find that 0, 2pi, and 4pi, 6pi, those will be value 1, function value 1, right? So in this case, we have 2pi k, right? And so we have 3 solutions. Any question? Yeah. 1 plus? So this is 1, and we are figuring out the angle, right? Inverse image of the angle, right? And so what I was saying was cosine of 0 is 1, cosine of 2pi is 1, and so on, right? And yeah. 1 is the function value when we evaluate at these angles. Any other question? No other question? So someone asked me about the factoring trick. So let me repeat it again. 2x squared minus x minus 1 equals 0. So what I was saying was you can solve it with any method. It doesn't matter, but factoring goes like, we look at the highest degree term and we think about this term, and we just combine two factors of this, whose multiplication becomes this. This one is prime number, is 1 times 2 or 2 times 1. This one is simple, 1 times 1 is the only possibility. So what we do is, after you list the numbers vertically like this, we will do cross multiplication and see what happens. 2 times 1 will make 2. 1 times 1 will make 1. The trick is, when you add these two numbers, this must be the number which appears in front of x, so -1 in this case. That can happen only if 2 becomes -2. Bigger one is negative. And indeed, we have to get -1 when we multiply. So we transfer that here. So what am I doing? Just indeed, it's just like a FOIL. This is first, and these are less. And one of these are inner and outer. And this is FOIL organized a different way. So this one is x, and just add. What did I do? By factoring like this, I thought about the first. And for this one, when we multiply, do two together, we are doing last, right? And this one is like outer or inner, which one it corresponds to. You can verify it. So we can write it as x minus 1 times 2x plus 1 equals 0. So if you feel like other method is easier for you, then you can continue to use it, but this is the method I used. For me, this one is the easiest one. Let's do the next problem. The next problem is about sine square root of theta equals 4 minus 2 times cosine square root of theta. The problem is a little bit harder in the sense the left side and right side contains same degrees and a second degree without common factor with different, so because those are different functions. But when it comes to sine squared or cosine squared, we know that we can convert that into different function, right? Sine can be converted into cosine, cosine can be converted into sine by using Pythagorean formula. So Pythagorean identity says sine squared is 1 minus cosine square root of theta, right? And so by doing this, I would convert the given equation into the normal quadratic equation to see how can we solve the problem. So I want to isolate cosine squared. So I would add 2 cosine square root of theta on both sides. Then this one will be gone. On the left side, I would have 1 plus cosine square root of theta equals 4. So I subtract 1 on both sides. So cosine square root of theta is 3. So cosine of theta equals square root of 3 or negative square root of 3. At first, you may think, oh, that is square root of 3. Maybe 30, 60, 90-degree triangle is involved, but indeed it is not. Why is that? Because in 30, 60, 90-degree triangle, cosine maybe 2/3. The hypotenuse is 2, right? So 2 must be involved to be related to the cosine. And when you evaluate square root of 3, we are getting about 1.7. And for this one, negative 1.7, right? And we know that this one is greater than 1, and this is less than negative 1, right? And the cosine value cannot be larger than 1 or smaller than negative 1. Therefore, this is impossible. And that means there is no solution. Any question? No question? Today I don't feel well, so I will end the class here. We will certainly be able to finish 6.5 and 6.6 until next week, and so it will not be a problem.